Hey everyone, welcome back. Today we're diving into a cornerstone concept in machine learning, residuals, and how adding variables transforms model performance. Ever wondered why some predictions are spot on while others miss the mark? Let's unpack the math behind the mystery. Imagine you're predicting house prices. You start with a simple model, just square footage. But there's always that gap between what the model predicts and the actual sale price. That gap is the residual, the unexplained variance in your data. Think of it as the leftover puzzle pieces after your first guess. Now here's where it gets interesting. What if you add a new variable like neighborhood median income? This could help shrink those residuals by explaining more of the variation. But how do you know if the new variable is truly useful? The answer lies in analyzing how residuals chain. If adding the variable reduces the residual sum of squares, the total of all prediction errors, you've got a winner. If not, it's probably just noise. But there's a catch. Adding too many variables risks overfitting, where the model memorizes the data instead of learning general patterns. That's where regularization steps in. It's like a mathematical break, penalizing complexity to keep the model balanced. Techniques like L2 regularization, RIG, or L1 LAS tweak coefficients to prevent overfitting, ensuring the model stays robust. Here's the deeper math. When you introduce a new feature, the model recalibrates existing coefficients to account for the new information. This adjustment is where QR decomposition becomes powerful. Think of your data as a messy room. QR decomposition orthogonalizes the new variable relative to existing ones, isolating its unique contribution. It's like sorting your clutter into labeled boxes, so you can see what's already explained, the orthogonal component, and what's new, the residual. This process is critical for understanding deterministic equivalence, mathematical approximations that simplify complex models. They let researchers predict how adding variables impacts residuals without brute force computation. Studies show that when data isn't too noisy, the right variable can drastically reduce residuals, like finding the missing jigsaw piece that completes the picture. But here's the takeaway. Residuals aren't just errors, they're clues. By analyzing them, we refine models to predict everything from stock prices to disease outcomes. And regularization ensures we don't overcomplicate things. It's the balance between simplicity and accuracy that defines modern AI. Next time you see a prediction, remember, it's not just numbers. It's the interplay of residuals, variables, and math that turns uncertainty into insight. Thanks for watching. Hit subscribe for more deep dives into the algorithms shaping our world.